Hi, in this video I'll show you how to crack the code that NSA tweeted earlier today. So looking at this code, the first impression is that we're going to deal with a substitution cipher. And the reason why is because we have characters here and characters which are grouped into 12 character blocks. Usually we would see an ongoing set of characters if there was some binary conversion taking place. But the 12 character blocks imply that someone went to lengths to make it into grouping and yet prevent us from using the length of English words to decipher what these words might be. So in English language we have words that are longer and shorter. Example right here, thanks for the shout out. Of course, the would be a 3-character word, and that makes it easier for us then to figure out certain details in the process. But the 12 character groups actually make it a little bit more difficult. We can see a special character, a question mark in the middle. What I don't see are double equal signs, which typically imply base 64. So we're looking at a substitution cipher. Well, let's bring up a tool and first do a copy and paste of this text. Let's go ahead and copy that. And this particular tool, which you can use other tools, will help us to analyze this particular code. So the analysis is going to help us to figure out our next steps. In the English language, we have certain frequencies of letters, and each language actually has its own frequency, which is why a lot of times with the substitution ciphers, you can figure out, first of all, what language the clear text is written, and then from there you can deduce what the actual message is. So in the English language, letter E is most commonly used, although there's an entire novel called Gatsby, which is written without a letter E in it. You can check that on Wikipedia. So if this was a long message, longer than what we have here, then we could actually trust these statistics. And there's probably a good chance that between letter I and N, in some combination, letters P and K do correspond. But because our message is fairly short, likely we don't have this in the right sequence. But if this was a longer message, we simply would substitute for letter P, letter E, and then for letter C, letter T, and then for letter I, letter A, and for letter D, letter O. All right, and so at this point we would have hoped to see some elements of English words. Actually, we would continue here with letter F, letter I, and K, N. All right, and so you can see that we have certain groupings here that, with enough fiddling, all right, would give us an idea of what correct sequence we have here. Okay, but we could spend a few hours doing it this way, and this would be the way to actually figure out the substitution cipher. There are automation tools, though, that will help. For example, the words that are in the English dictionary are in digital form. So a computer program can randomize these letters much quicker than we can and then try to detect English words. Another way to play with this text is to use some of the tools that are already online. So let's Google substitution cipher, and we want to use a JavaScript because JavaScript allows us to work just in the browser. It's not a server-side technology, so that our ciphertext could be perhaps saved and then cracked by someone else. So the first website here gives us a tool like that. So we have a nice introduction about what substitution ciphers are, and Caesar cipher, of course, is a great example of that. And as we scroll down, we have an example application. Now, all I have to do at this point is just try it out. I will say decrypt, and oh, look at that. This is actually the perfect random key, which is actually embedded in this website, that lets us to decrypt want to know what it takes to work at NSA. So there it is. Possibly when this message was being created, this website was used to encrypt the code. At any rate, cracking code sometimes does involve a fortunate sequence of events. If you are serious about playing with cracking code, I would recommend Backtrack, which is a Linux distribution with a number of tools which will allow you to get that level of automation that I mentioned before, where the English dictionary is used, and you'll have more success with cracking code. Finally, I also want to recommend Khan Academy videos on cryptography. Now, you can click any of these links here, but they will take you to Khan Academy recordings, which will introduce the Caesar cipher. It'll introduce you to cryptography in general, but then also explain how you can detect languages and through substitution ciphers, and just a really nice entry-level lessons on cryptography. If you'd like to see what the NSA message looks like when it is decrypted by hand, this is what the combination of the characters and then the ciphertext characters line up looks like. Thank you very much.